Hello students, welcome. Previously, lesson 16, form 4, topic 4, we were dealing with the nature of electrode use, which was the third factor affecting the preferential discharge of ions during electrolysis. So today, lesson 17, we want to proceed to the applications of electrolysis. So we're having the first application, which is extraction of reactive elements. So we're saying electrolysis is used in the extraction of reactive elements such as sodium, magnesium, aluminum, and chlorine. So learners, you have to know that when we are dealing with the chemistry of metals, when we are doing extraction of metals, we say the elements or metals are extracted using two methods. The first method was by the use of electrolysis method, and we said more reactive metals such as sodium, aluminum are extracted using the electrolysis method, while the less reactive metals such as lead, copper, and iron, we see they're extracted by using the reduction method, using a suitable reducing agent such as carbon and also carbon dioxide. So we are going to go to the second application of electrolysis, which is electroplating. And we are saying this is the process of using electricity to coat one metal with another. Next, we are saying the metal used for electroplating is usually less reactive and serves to protect the object from corrosion. Then we are saying the coat is then polished to give a shiny appearance. For example, we are saying gold-plated watches and silver utensils are common items. So we are going to go to the first electroplating, which is silver plating. And we are saying silver plating is done on cutlery and also jewelry. So cutlery include knives, spoons, and also cups. So we say next the object to be electroplated is first polished thoroughly. It is then made the cathode in an electrolytic cell, and we are saying the electrolyte is a solution of silver salt or a solution containing silver ions. Then next the anode is a pure silver rod, and we are told direct current from a battery is used. Remember, when we are going to do electrolysis method, we are supposed to have three things there. We are supposed to have the electrolytic cell, and we say the electrolytic cell, it is the cell where electrolysis takes place. Then next we are supposed to have electrolyte. So in our case here, the electrolyte will be a solution containing silver salt or silver ion. For example, we can use silver sulfate solution, or we can use silver nitrate solution. So electrolyte, we said, is a substance that undergo electrolysis. So next thing, you're supposed to have electrodes. What are electrodes? We said electrodes are two solid substances or solid materials that are dipped into the electrolyte during electrolysis. So in our case, we are having the anode and also the cathode. So that in the anode is made up of a pure, or is made of a pure silver rod, while the cathode is made by the quartz. Then we're saying next, when a current is switched on, the following reactions occurs in the cell. So that means we are going to see the reaction taking place at the anode and the reaction taking place at the cathode. So remember, at the anode, we are having silver solid, which is going to lose one electron to form silver ions, or silver ions which are in solution. So silver solid or silver rod, which was made up of the anode, loses electron and goes into solution as silver ions. What about at the cathode? At the cathode, the silver ions which are in solution will acquire electron, or will gain one electron to form now neutral silver atom. So that will be the silver coating. For example, if we were dealing with our cutlery was made of maybe a cup, then that means we are coating the cup with silver. So it will be having the silver coating. So we say next, the silver ions that are formed at the anode go into solution, replacing those that are discharged or those that are used at the cathode. So this is the cell where we are going to do silver plating. So we're having solution containing silver salt or silver ions. Then we are having the cathode made up the object to be electroplated. Then we are having the anode made up of pure silver rod. Next we are going to go the other again example of electroplating, which is chromium plating. When we are saying it is done on motor vehicle doors, handles, wheel rims and bicycle handlebars, and we are told this gives them a shiny appearance and protect them against corrosion. Then the third, we're having gold plating. So we're saying gold plating is done on precious items such as jewelry and watches, and we are told this gives them an attractive appearance and protect them from corrosion or against corrosion. So we go next to the third application of electrolysis, which is sacrificial protection. And we're saying iron or steel structures are protected from corrosion through sacrificial protection, either by galvanizing or cathodic protection. So we go to the first, that's cathodic protection, and we're saying corrosion involves loss of electrons by an element to form its ions or to form ions. If a less reactive metal is connected to a more reactive metal by a conductor, when the conditions for causing corrosion are present, we are told the more reactive metal ionizes at the expense of the least reactive metal. Then we are told the more reactive metal is sacrificed, and the method is called sacrificial protection. For example, if we're dealing iron and we're having iron as our less reactive metal and we connect it with a more reactive metal like zinc and using a conductor, when the conditions of causing corrosion are present, we are told zinc metal ionizes at the expense of iron. That means zinc metal is sacrificed, therefore this process is called sacrificial protection. So the second is called galvanizing. So we're saying when galvanized the surface is scratched and iron is exposed, we are told zinc passes into the solution as zinc ions rather than iron 2 ions. This is possible because zinc is easily oxidized than iron, or this because zinc is more reactive than iron. Next, the fourth application of electrolysis is called purification or refining of metals. So we're saying when copper is first made from its ore, copper metal is about 99% pure. The impurities present in copper include iron, zinc, silver, gold, and platinum. And we are told their removal is called purification or refining. And we're saying during the purification process, a bar of impure copper is made the anode, while a thin sheet of pure copper is made the cathode. Then we are told the electrolyte consists of copper 2 sulfate solution. So this is what is going to happen when we are going to do purification process or refining of metals. So here we are having pure copper cathode made at the cathode, while the anode is made by impure copper, and we're having our electrolyte being solution containing copper 2 ions or copper 2 sulfate solution. So this is at the start of the electrolysis process, but after or near the end of electrolysis, this is what's going to happen. So we are going to have pure copper. Initially it was thin, but now it has been coated by a pure copper on the copper cathode. What about the anode, which was made up of impure copper? It became thin because the pure copper loses electrons and goes into solution as copper 2 ions, and we are having here slags. So we're saying when the current is switched on, the following reactions occur in the cell. So we want to see the reaction that's going to take place at the anode, and the reaction that's going to take place at the cathode. At the anode, we're having copper rod or copper solid, which loses 2 electrons to form copper 2 ions. And we said copper 2 ions goes into solution. At the cathode, we're having copper 2 ion solution gaining 2 electron loss from the anode to form neutral copper solid, which will be coated on the copper cathode. So we're told, note, at the cathode, copper 2 ions are discharged, forming a coating of pure copper over the copper cathode. The copper 2 ions that are formed at the anode go into solution, replacing those that are used or those that are discharged at the cathode. Then next we are told active metals like iron and zinc from the impure copper bar also undergo oxidation and they lose electron and goes into solution. They are, however, not discharged at the cathode because copper 2 ions are more readily reduced and are present in much higher concentration. So the reason why copper 2 ions are discharged at the cathode is two reasons. One, we are saying they are more readily reduced. So that means they have high tendency of gaining electrons compared to zinc ions or iron 2 ions. And the second reason we are saying is that copper 2 ions are in a high concentration, so therefore they will be preferably discharged in the cathode over iron and also zinc 2 ions. So next, inactive metals like silver, gold and platinum are not oxidized, but fall off under the anode and settle as sludge. The metals in the sludge are valuable and they are recovered. Learners, that's the end of our class today. Thank you for watching.